Okay, so we're doing a three-part review for the final, and this is the third part of the packet now. We're covering problems 24 through the end of the packet, and this is covering rational functions. Remember, those are rationals, they're like fractions. Everybody get on this problem, number 24, and do you remember about the horizontal and the verticals and the domain and all that kind of stuff? Do you remember generally what these fraction functions look like? Well, if you don't, I'm going to be telling you right now. So this guy, I can factor the top, and I have a little rule in math. If you can factor it, you probably should. I throw in the probably because I suppose there's now and then situations where you don't need to factor it, but if you can factor it, you probably should. And look what happens. On the top and the bottom, I have something identical, and they cancel. And then I should write down the resulting function, which is y equals 5. And if you've forgotten how to graph a simple straight line, this would be hard for you, but hopefully you can do this. It's just like that. Now, what's wrong with my line, though? It's supposed to have a what in it? A hole. And where is the hole? Well, how you find a hole is you figure out what number makes that hole, like 3 for x is what would cause the problem. You don't plug it into the original problem, or what will happen is you'll have 0 over 0. That's the point of a hole, is that number 3 does not work well. So if you want to know where it is, it's at 3 comma something, and you plug it into the resulting function. Do you get that no matter what I plug into this, it's always going to be y equals 5? Therefore, it's at 3 comma 5 is where the hole is. So I go over 3 and up 5, which is right there. I put an empty spot. I make sure that there's actually an open spot in the line right there. There's the correct graph for number 24. Any questions on that kind? All right. Now, if that had come out to a more normal one, I just want to remind you how those look, because you will have to graph those kind too. What if it had come out to something like this? 1 over x minus 3. Do you remember how that, I like to think of this as a butterfly one. And I can give you a long explanation of why, but if you go like this and then like that, see how it kind of looks like a butterfly? Anyway, if you have this function right here, and it has a hole in it at, let's say, 3, then you go like there, put an empty spot right there. There's my fraction rational function that has a hole in it. That would have been if it had been like this. And this had canceled, and then there'd been a hole at 3. All right, so moving on. Number 25. The first thing they ask you for is the domain. But before that, if you can factor it, you probably should. So I see something I can factor here. The top can factor and the bottom can factor. And I bet you that something will probably cancel, creating a hole. So this has a 2x in it on the bottom, and then I'd have an x minus 4. So I bet you there's an x minus 4 on the top. That'd be the way I'd do it. And then I'd just see if there's a chance that x minus 4 works up here. X minus 4, and then x, and then how do I get a 24? Plus 6. 6 times 4 is 24. Let's see if that works. Outside and inside make positive 2x. Look at that. It worked. And my guess of this canceling was right. Of course, I made the problem, so it's kind of cheating. But it usually happens that we make them so something cancels, so that creates a hole. Then the resulting function would be, in the end, x plus 6 on top over 2x on the bottom. So the domain for this guy, all reals except x cannot be 0 because of that. And x cannot be 4 because of that. Does that look right to you? I think it's right. Now there's a question. Do you still have a question? Or? All right, let's move on. The vertical asymptotes. Well, I like to think of it this way. These guys right here are either holes or asymptotes. Because if they are disrupting your function enough so that they are the things that won't work. See, this is all reals except, these are the only 2 exceptions in the whole world out of billions of numbers. Those 2 are special. They make holes or asymptotes. And this part right here, that was an x minus 4 canceling each other. That was the hole. So the hole part is the x is 4, comma, what? Then you put that 4 into this function right here. And I'd have 4 plus 6 over 2 times 4. That would be 10 over 8. 10/8 10/8 reduces to 5/4. So that goes right there. That's how you tell where the hole is. You take the x of it, which we knew from the domain, and then we plug it into the resulting function, and it tells us the y of our hole. All right, the vertical asymptotes versus the horizontal asymptotes. Well, the horizontal asymptotes are the ones that Bob will tell you. The horizontal are the horizontal. Do you remember that? The y. And the vertical are like the zertical. Those are the x equals things. Remember how these were going to be either asymptotes or holes? Well, we figured out that one right here was a hole, so that one right here must be an asymptote, but which kind is it? If you know the rule about how the verticals are the zerticals, you remember that this must be one of these kind because it's an x equals thing. X equals 0 is where the vertical asymptote was. Then the horizontals, Bob tells you about the horizontals. And the rules for horizontals are either it's bigger on bottom, bigger on top, or same on both. And that's talking about the degree. Well, our resulting function's right here, and it's same on both, right? They both have a degree of 1. Degree of 1, degree of 1. It's not about the other numbers, it's just about the degree. So the degree was same on both. Therefore, it's a ratio of the lead coefficients. The lead coefficient here is a 1. The coefficient's the number on the x. Here's the 2, so it's y equals 1/2. That's the ratio kind. The same on both is a ratio. I'm going to write this down for you in case you need it for your notes. Same on both are ratios. Bigger on tops, those are no, as in no bots. Remember that? There's no asymptote if it's a bot. And the last kind is Bob's. And it's a bigger on the bottom. And if it's a Bob, it's a y equals 0 unless there's something on the outside. There was nothing on the outside of my fraction here. Like if there was a +5 out there, it would change from a 0 to a 5. But if there's nothing on the outside, it's just y equals 0 for Bob's. So you could think of Bob as a 0, but it's also kind of an outsider. Because if there's something on the outside, you change your 0 to that. Okay, that's a reminder of how you do that kind. There was a lot of topics right there. Any questions in there? Like, how do you get these again, or anything? Okay, let's move on. Number 26. That one's just a hole. We just showed you how to find a hole, so it would be a good one for you to practice. Once you factor the top and bottom, once you know the number that works as the hole, you got to just make sure you answer it in this format. Let's say you think it's 3 that works. You got to figure out what the y is by plugging that number back in to the resulting function. All right, write an equation for this graph. This graph that is given to me here has a hole in it. I recommend on this kind of problem that you do not factor in the hole at the beginning. You just ignore that. And you say to yourself, what's the equation for that line if it didn't have a hole? Has anybody already got that? 1x minus 3, that's kind of close, except the slope is bigger than 1. The slope in this case is 3, because if you go from here to here, you can see it went up 3 and over 1, so this is 3x minus 3. Yeah, I did that. That's the slope. That's the y-intercept. Okay. Now, if I want to include the fact that it actually does have a hole in it, then I got to say this part needs to have 2 sets of parentheses that will cancel, that will make the hole. And one more thing. That needs to be in parentheses too. So the part that's a hole is an x and an x, and you need sometimes a minus, when a 1 on minus on top, 1 minus on the bottom, sometimes it's a plus. I know by looking at this 2, that's a positive 2, so it needs to be minus 2, minus 2. There we go. There's my equation for that graph. And it is about lunchtime. I'll pause and we'll finish this after lunch. Okay, here we go. Coming back from lunch, and we had just finished up number 27, which was a nice little equation for a line that had a hole in it. And remember, you do the equation part first, and you do this hole here last. Then you just slap that on to whatever the equation was. Okay, now on to 28. Everybody turn to 28 with me, even if you're not done with 27. Okay, which of the following have an horizontal asymptote of -7/3? Okay, Well, horizontal are the horizontals, the y equals things, so that makes sense, horizontal and y equals. And who tells you those? Bob. And is this a bigger on bottom, bigger on top, or same on both? Well, you got to ask that for each of these. Is this one bigger on bottom, bigger on top, or same on both? That's the same on both. And if it's the same on both, it's a SOB. SOBs are an SOB to figure out. They make you SOB, whatever, however you want to say it. They're the hard kind. They're the ratio. This guy would have a ratio of 3/2. This one is a bigger on bottom. It's a Bob. What's the deal with Bobs again? Y equals 0. This one is, let me think. I got to multiply them out in my head, kind of. It's x squared on top, and it's x cubed on the bottom. That's a bigger on the bottom, because there's x at x and another x, and when they all get multiplied by x to the third. So this is bigger on the bottom, y equals 0. And the last one must be it then. Same on both, so it's a ratio, and the ratio is 7/4 actually. So bottom line is, actually, there is no correct answer for number 28. Oops. I think they're changing the packet to, I just talked to somebody about this, and they're going to change the packet to just find the asymptote for all of them. So if you want to write those down quick, that's what we want you to do on this one, is write down the asymptotes for A, B, C, and D. I'll leave them up there while I start number 29. Number 29, identify them as arithmetic or geometric. Well, the kind where you add are arithmetic, add or subtract. The kind where you multiply, like this kind where you're multiplying by 1 minus 0.05, that kind, and this is another one of those kind where you multiply. What kind are those? Geometric. Okay, so these two are the kind where you're adding or subtracting. So those two are arithmetic. The ones I circled, those are geometric. Using the recursive formula below, what would the first 4 terms of the sequence be? Don't need to break out the calculator when you're only talking about taking 2 and then subtracting 3 from it. 2 minus 3 would be -1. Then I subtract 3 again, and I'd have -4. Subtract 3 again, and I'd be down to -7. It's kind of like the temperature in Minnesota. Ugh. I can't believe it's cold again. It's going to be cold again tomorrow. It's just brutal. It's spring. It's supposed to be nice by now. Not nice, but at least should be in the 30s or 40s. All right, moving on to number 31. Using the recursive formula below will be the first 4 terms of the sequence. This one I might want the calculator for. The first term's easy. It's 10. And the next term's not that hard. I just have to multiply by 1 minus 0.2. Well, that's the same as 0.8. I can multiply by 0.8 in my head, but it's going to get a little harder after that. 0.8 times 10 would be 8. And then I got to multiply by 0.8 again. I could do it. 8 times 8 is 64. 6.4. Yeah, and the final one's going to be just too tough for me. 6.4 times 8 again. You'll figure out the last one. Now you can put that into the calculator if you want with the whole sequence thing, but I'm definitely going to do that for this next one. So I'm going to go to 32 and show you how the calculator would work for that one.
Are you recording?
I am recording, and it's running, don't worry. See the little numbers changing there? Number 32, actually I don't even have to put that in the calculator, because it's just, is it arithmetic or geometric? Well, that's pretty easy. It's going down by 5 the first time, and then it goes down by 4.5 the next time. That's not going down by the same thing every time, so it's not arithmetic. It's not an adding one. Therefore, it must be geometric. Next, does it represent growth or decay? Well, it's getting smaller and smaller. That's called decay. What is the percent change for this sequence? To get the percent change, I do 2 things. First, I divide 45 divided by 50. And this is kind of, but since I don't have a calculator, I'm going to scale this up to out of 100. That'd be like 90 out of 100. And then that tells me the decimal is 0.9. That is not the percent change. That 0.9, what I should do with it is go like this. 1 plus something or 1 minus something will equal 0.9. It's minus something. 1 minus 0.1, will equal 0.9. Now that I've gotten it written that way, that's the percent change, which is it's dropping 10%. So I would, you could just call it 10% change since they didn't ask if it's growth or decay. All right, we already said it was decay up here, so that would imply negative. And the last one, write a recursive formula for this. Well, since it's asking me for just terms, it doesn't have any real world context, it isn't talking about antelope populations or whatever, I'm going to use U1. If it had been a real world problem, I would have used U0. U1 equals 50. UN equals UN minus 1. And then I need that exact thing I wrote right here. 1 minus 0.1. And then you got to say n is greater than or equal to 2, and that's called the domain. Don't forget that little part or you lose half point every time you forget the domain. That happens to some of you on the test. The max I took off for making domain mistakes was 1 point. You could lose a half and then you could lose another half, but then I stopped the torture because otherwise you'd have lost like 4 points, and that's pretty rough. Okay, number 33. This one I'm going to definitely need the calculator for. So 1,000 and you're earning 2.5% interest. Man, I saw a lot of mistakes on that. A lot of people put it in the calculator U1. First of all, you shouldn't do that. It should be U0 because it's a real world problem. Unless they give you the year, which they didn't. So I'm going to go with U0. U0 equals 1,000. And then I saw a lot of this. People did not know what to put in that parenthesis. You should have put 1. And is this growing or decaying if you're putting money into the bank? It's growing, plus. And then how much is it growing? And this is where people screwed up. It's not 2.5 right there. 0.025. A lot of people did that wrong on the test. So get this number straight or your answer won't make any sense when you're done. 0.025, because that's what the decimal is for 2.5%. You're supposed to use a decimal right here. So you just have to say 0.025. All right, now I got to put that in the calculator and see how many years it takes before it doubles. I'm going to pause for a second while I put it in the calculator. Okay, so now that I'm in sequence mode, I start with UN equals U sub n minus 1. That all looks good. And then I'm timesing by, I got to see what I should use this. 1 plus 0.025. So I'm going to have 1 plus 0.025, end parentheses. Make sure there's nothing else after that. I had a payment before on my previous problem, I think. Remember, that's where the payment would go. If they had like an extra yearly payment, you'd put plus 1,000 there, or whatever your yearly payment was. And then the amount it started with. This problem started with a 50, so I'm going to put a 50 right here. I don't need another equation for down here, so I'm just going to clear this one. Oh, is there one? Was it 1,000? Oh, I'm looking at the problem above it. Sorry. You're right. It starts with 1,000 on this one. Okay, change that to 1,000. Okay, then I think I've got it all set up right. I don't need this second equation here, but I hate to delete it because I'll have to replace it all if I have to compare two things. But I'll clear it. That's okay. I don't need it for right now anyway. So now I'm going to go to my table. My table is taking a long time to run. This will happen to you at some point also if you have your table settings set kind of funny. All right. What I wanted was U sub. Well, I wanted to know when it was paid. Was it paid off after 10 years? Okay. 10 years would be U sub 10, right? So, unless we were in months, but that's going to come later. We'll do the monthly stuff later. I really wish I had my table start at 50. So I'm going to go back to table settings and use my table settings thing to make it go back to 10. And now when I hit not graph, I'll break that and go to table. Come on, calculator, catch up to me. There we go. It still has a balance. So It should have a balance. It was a savings account and it was growing. How much is in the account after 10 years? There it is. 10 years, $1,280.10. 1,280.10. After how many years will the account double in value? Well, I need to know when it's going to hit 2,000 because it started with 1,000. If they want it to double, I just got to keep hitting the down arrow here until it eventually hits 2,000. You guys got it already? 29. Thank you. It'll tell me when to stop here. There we go. There it is. Now don't say 28 or 29 on the test because you'll get it wrong. After 28 years, do you get we're on the 28? If you look right here, at the end of that year, this is how much you have. Now granted, you're really close to 2,000, but you are not there yet. So the right answer is 29 because it has to be during the 29th year that you will hit the number we wanted. So a lot of people make the mistake of saying the last 2 years. Don't do that. Wait till it's actually paid off, or in this case, till it actually hits 2,000. Wasn't until the 29 there. All right, so the answer is 29. Did it break? Okay, good. Okay, so that's how to do those kind of problems. Let's, I'll leave one of those for you to try, like number 34. And this one, the only hint I'll give you here is it's supposed to be 1/5. If you divide 1 divided by 5 and it gives you 0.2, sorry, 0.2 is your decay factor, and if you put that into the calculator, you'd put it in like this. U0 equals 22,000. UN equals UN minus 1, and then right in here is where everybody makes their mistakes. Should that be 1 plus 0.2? Should be 1 minus 0.2. It's going to lose 20% of its value. 1 minus the 0.2. Okay? And then that's not done yet. You have to make sure you write your domain for it, and then you'd use the calculator to figure out what U sub 5 is and how many years. You have to just keep going through the table until you find out where the car is worth less than $1,000. It is sad but true. Those brand new cars that start out worth 20 grand are eventually sold for like $1,000. It's just a matter of time. Unless you buy really, really fancy cars, in which case they still go down a lot, but if you have a $100,000 car, when it's really old, it's probably still worth like 20,000. Yes? When you go back and forth between the modes, it's under mode. So if I just go to mode, that button right there that's red now, the mode button will change it back and forth. And you're changing it between function mode and sequence mode. So function mode is for anything except those recursive sequence problems. So anytime it's only one part of the test where you'd want to go to sequence mode. Whole rest of the test, you'd want to be in function mode. Yes, sir? It's a good question. I want the whole thing done by tomorrow. It'll really help you. And you'll be surprised how hard some of the other sections are. So I know it's a lot to ask for tonight. I did do a good chunk of your worksheet with you in class here. I know that leaves probably out of 34 questions. You probably still we're going to walk out of here with at least 20 to do, I know. But if you don't practice them, you won't do near as well. And this test is counting on your quarter grade for everyone, and it'll be your last chance to raise or lower your grade. Besides, I know tomorrow and the next day are going to be easy peasy days, so get it all done tonight. Hold on just a sec. Let me stop my video, and that's all I have for that part of the video. Remember, you can watch the other 2 parts of the video. They're also posted today.